Welcome to this explainer. Okay, let's dive into a topic that might actually catch a few traditional web developers completely off guard. Today, we're exploring the surprising reality of using PHP and Laravel to power the Internet of Things. Yeah, you heard that right. If you've ever wondered how the elegant MVC architecture of Laravel translates from standard web apps over to managing a network of connected smart devices, well, you are in exactly the right place.
Before we jump in, here is our quick roadmap for today's explainer. First, we'll meet Laravel for IoT. Second, we'll break down the IoT architecture. Third, we'll look at a real-world, smart farming use case. Fourth, we'll walk through building your backend. And fifth, we'll cover some essential best practices and pitfalls.
All right, let's jump straight into Section 1, meet Laravel for IoT, and see how PHP actually powers the Internet of Things.
Now, this is the big question, isn't it? Can you actually use Laravel to power smart devices? You might intuitively think that managing connected fridges, smart thermostats, or fitness trackers requires some completely new, hyper-specialized backend stack. But honestly, that's just not true anymore. Laravel provides a remarkably clean, flexible, and scalable foundation for this exact purpose. It takes the PHP framework you likely already know and love and totally repositions it as a powerhouse for managing hardware data.
To really grasp how this works, we have to look at how these systems are structured. The Internet of Things is essentially a network of physical devices connecting to the Internet to collect and exchange data. I like to think of these physical devices, whether they're home appliances, medical devices, or wearables, as the census. They're out there in the real world, touching, seeing, and measuring. Laravel, on the other hand, steps in as the server-side brain. It's receiving, processing, and making sense of all that raw sensory data.
And this beautifully illustrates exactly why Laravel stands out in the IoT development space. Just look at these benefits. First off, you get rapid development through clean code and built-in tools like the eloquent ORM. Second, IoT devices primarily talk via APIs, and Laravel's routing makes building secure REST APIs an absolute breeze. Third, scalability. As your network grows to thousands of devices, Laravel scales horizontally right along with it. Add in standard security features right out of the box, plus seamless compatibility with the cloud, and you've got a ready-made enterprise-grade backend.
Which brings us to Section 2, the IoT architecture, and exactly how that data flows.
Let's walk through this step by step, because once you see the data flow, it all clicks. Step 1 starts at the edge with your IoT devices, those sensors gathering the data. Step 2 is the communication protocol, which acts as the messenger. Step 3 is our Laravel API backend, the central brain processing those incoming messages. Then, in Step 4, Laravel stores this in a database, like MySQL or Redis. Finally, in Step 5, Laravel serves that processed data right up to an interactive web dashboard. So information flows sequentially, straight from the hardware sensors directly to the user's screen.
Now, what's really fascinating here is the communication layer. While REST APIs and HTTP are perfectly fine, and obviously Laravel handles HTTP natively, IoT often demands something much faster and more specialized. That's where MQTT comes in. It's an incredibly lightweight, publish-subscribe protocol built specifically for IoT. Now, Laravel itself can't act as an MQTT broker, but it can effortlessly communicate with one. By integrating official packages like PHP MQT, Laravel can consume real-time device messages using scheduled jobs or workers. It's literally like a lightning-fast superhighway for your data.
Let's ground these technical concepts with Section 3, a real-world smart farming use case. Let's look at Laravel out in the field.
Imagine an agricultural setup designed to optimize irrigation. Step 1. Soil sensors collect moisture data out in the dirt. Step 2. Laravel receives this data through a dedicated API endpoint. Step 3. The backend logs the reading and runs a quick logic check against predefined moisture thresholds. Step 4. A farmer checking their Laravel-powered dashboard sees the real-time readings update instantly. And Step 5. If the moisture drops too low, Laravel actively triggers an automated command back down to the hardware to turn on the irrigation. It's a simple, elegant loop powered entirely by Laravel that actively saves water, time, and money.
Moving right along to Section 4, building your backend. Here is your step-by-step guide.
If you're a developer wanting to actually build this, the execution is incredibly straightforward. You're using tools you already know, and you can literally build an IoT backend in 5 steps. First, install your new Laravel project. Second, define your API routes where devices will post their data. Third, create a controller to process and store those incoming metrics. Fourth, lock it down. Secure those APIs using Laravel Sanctum so only trusted devices can connect. And fifth, display that data dynamically on a dashboard. Boom! You're building a secure hardware backend without having to learn a brand new programming language.
And to really supercharge your build, the Laravel ecosystem provides officially supported tools that feel practically tailor-made for IoT. You can use Laravel Horizon for visually managing heavy analytics queues so your server doesn't get bogged down. There's Laravel Telescope, which is an absolute lifesaver for debugging massive amounts of API activity from chatty devices. Sanctum handles your token-based authentication seamlessly. Livewire lets you build those real-time interactive dashboards. And the Laravel Scheduler? It's perfect for running automated device health checks. It's just an incredibly robust toolkit.
Finally, let's wrap up our blueprint with Section 5, Best Practices and those essential guardrails.
Interacting with physical hardware introduces some very unique challenges, so you absolutely must apply these guardrails. First, rate limit your device requests to prevent a malfunctioning sensor from spamming your server. Second, never trust incoming device data blindly. Validate every single input. Third, and this is absolutely crucial, use queues. Offload time-consuming tasks so your devices don't hang up and time out due to server latency. Always encrypt sensitive data, keep all your business logic centralized in the backend, not hard-coded on the device itself, and use try-catch blocks so when a device inevitably drops offline, your system fails gracefully.
But hey, part of being a great architect is knowing your tool's limits, right? It is just as important to know when not to use Laravel. It's phenomenal for web-connected dashboards, API backends, and centralized device management, but you should never use it for embedded microcontroller development. If you're working directly on an Arduino, you need C++ or MicroPython. It's also not the right tool for ultra-low latency edge computing or offline-first scenarios where an internet connection just isn't guaranteed.
This quote right here from the source material perfectly summarizes everything we've explored in this explainer today. Laravel doesn't replace embedded software. It shines as the back-end brain of your project. And that totally hits the nail on the head. Laravel isn't some gimmick trying to do something it wasn't built for. Rather, it is the highly secure, incredibly scalable bridge connecting raw hardware capabilities to the infinite potential of the cloud.
From agriculture to healthcare, and from smart homes to industrial automation, Laravel is helping businesses innovate smarter and faster. So, now that you have the complete blueprint for how this works, the only question left to ask is, what physical device will you connect to your Laravel brain next? Think about the possibilities. I highly encourage you to dive into the documentation and start building today. Thanks for joining me on this explainer, and I'll catch you on the next one.